Okay, we can control our temperature, body temperature. So we are called homeotherms. So homeo, same, and then temperature. So we're known as warm-blooded. So if it's cold around us, we can do things that'll help us keep warm. Right, how do we do that? That's the question. And these are the questions that will come up. So our normal body temperature is, give or take, 36.9 degrees Celsius. So now in the book it says plus or minus 0.7 degrees. So that's a typical range for a normal human being. Oh, by the way, in case you're interested, ducks have a temperature of 43.1 degrees Celsius, give or take. Why that is, I don't know. Must be burning loads of fuel. It's cheap energy. Anyway, let's move on. Right, human beings have a area in the brain called the thermoregulatory center. Yes, that's the British spelling. Sorry for the US students. Thermoregulatory center. This lets the body know whether you lets you know that whether you're too hot or cold, and then whether you need to start sweating or putting on extra layers or taking off layers of clothing. Right, so our habits can, basically what we can do is we can drink a warm drink. If we're cold, we can put on an extra layer of clothing, extra clothes. Right, we can turn on heating or whatever you want. In the other way, we can, if we were too hot, you can drink a cold drink. You can take a layer off. You can turn off the heating. You can also start sweating to help cool your body. You can go for a swim. So all these are sort of habits that we can do. But what we're interested in, and the question that's most likely to come up for you, is this. If you go from a cold to a hot place, what will happen? Right, what you can do is say, so let's go through this. There's your skin. That's a hair. This here is a capillary. So there's a network of capillaries running. So that's, here you've got a layer of skin. Well, the fatty part, that's the this is the fat in the skin. These are capillaries, and in this case it's a loop. This is a capillary loop. That is a hair. Right, let's get this other stuff in there. So you've got that there's a sweat gland. So that's the paw. That there is the sweat gland. Right, and then you've got these other little things. How can we draw them? Okay, so in your skin you've got pain receptors and you've got pressure sensors. So these all give feedback to your body that if there's something wrong or if something's changed, you can detect it in the environment. So let me get this right. So you have here, what color? Okay. So let me just go over that. The top bit is called the epidermis. Let me squeeze it on there. The middle bit is called the dermis, and the bottom bit is called the hypodermis. So this is the structure of your skin. Right, to the base of that hair, you've got a hair erector muscle. Right, now bearing all this in mind, now what's going to happen is your body's going to behave in such a way to help you regulate your body temperature. Okay, so what we're going to do is we're going to go from a cold to a hot room, and this is how the question is. If you go from a cold to a hot room, how does your body regulate its temperature? So what happens is the sweat gland produces more sweat, and when that evaporates, it cools the body down. This evaporates, cooling the body. Right, that's step one. Right, the next step, this hair erector muscle, the hair erector muscle relax, making the hair lie flat. What's the benefit of that? Well, what that does is it stops, or doesn't, it stops air being trapped, and air is a good insulator. So there is less insulation. That means more heat can escape. And the third thing, is these capillary loops. What happens is you've got, let me draw this here. So let's carry this on. So what happens is you've got your blood flowing in this direction. When it's cold, these capillary loops constrict, so the blood continues flowing in that direction. Okay, so now when it's warm, let me turn that to green, blood flows along here. These capillaries vasodilate, they get bigger, so then blood starts flowing up here and it flows to the surface of the skin, and your face will become red and feel hot. That's because there's blood flowing close to the surface. That then allows heat to radiate outwards, and it also help evaporate any sweat produced. Okay, so we need to write that down, so let's write it down. Let me move that up. Right, so what happens? So the capillary loops open up, but we use the word vasodilate. It's like with the eye, when the pupil dilates, vasodilates, it opens up, allowing blood to flow to the surface of the skin. This means that the heat can radiate away. It also helps the sweat evaporate as well, cooling the body down further. So the question, this is what happens, this is what's going to happen. They're going to ask you a question. Let me just write this down. Right, so quickly to summarize. If you move from a cold to hot place, what will happen is the sweat glands will make more sweat. This means that there's more evaporation taking place, cooling the body down. The hair erector muscles here will relax. What will happen is the hair will flatten. That means that there's less trapped air, and because air is a good insulator, there'll be less insulation, so you can lose more body heat. So that's the hair erector muscles. Finally, the capillary loops, these are this bit here, they open up, they vasodilate. That means that blood starts flowing up closer to the surface where the heat can evaporate. So the capillary loops vasodilate. It's important to get these words in. Allowing blood closer to the surface of the skin. This means that heat can radiate away more efficiently. And vice versa. You'll do it the other way as well. So it depends on what sort of question they ask you.